Hi Geometry. This is part of our review for Algebra 2. So first of all, looking at numbers 1 through 4, these problems are asking us to review the distributive property. That's when I want to multiply something on the outside of my parentheses times everything on the inside of my parentheses. I want to distribute this times 9 to both terms inside. And 9 times x is 9x, and 9 times 5 is 45. So now this particular outside term has an x with it. So now I have an x to the first. So let me, with my Apple Pencil, try to put a really tiny one, times another x to the first. When you multiply bases with like bases, you're really, this is times, sorry, x to the first times x to the first is going to give me x squared. I'm really adding those exponents. That's the rule for multiplying with like bases. So this would be 7x squared minus 21x. So now I have another 2x to the first, and I'd like to distribute it to all three of the terms inside my parentheses. So x to the first times x squared, again, I add those exponents. That's going to give me 2x cubed. If you think about x to the first times x squared, this is really x squared is x times itself. It's really 3x's being multiplied. And then plus 6x squared minus 8x. And lastly, notice there's a negative sign in front of my 5. So this will be negative 5 times 6, which is negative 30, x times x, which is x squared. Negative 5 times negative 3 is plus 15, and there's nothing to combine my x with, so it's just going to be my plus 15x. So now, why did we review that? Well, factoring is basically reverse distribution property. You look for the greatest common factor. We call that the GCF that you can factor out. So in numbers 5 through 8, it's asking me to look for the largest integer. So I'm not looking at the variables at all. I'm looking at my integers to see if I can find the largest integer. That's my greatest common factor. So I'm looking at the 9 and 45. And they both have 3 in common. 3 is a factor of both of them. But when I'm looking for my greatest common factor, I'm looking for the greatest integer, the largest integer that will divide evenly into both. So 9 would be my GCF. 9 goes into 9 one time, and 9 goes into 45 5 times. 7 and 21 both have a 7 in common, so 7 would be the greatest common factor. 7 goes into 7 one time, and 7 goes into 21 3 times. Now 18 and 12, some students might look at this and say, oh, they're both even, so it's 2. But it's not 2. 2 is not the greatest common factor. You might look at 18 and 12 and realize, oh, 3 goes into both of them, and you would be correct. But again, it's not the greatest common factor. The greatest common factor that divides evenly into both of these is 6. 6 goes into 18 3 times, and 6 goes into 12 twice. 15, 25, and 55, their GCF, we might be thinking, since they all end in 5, their GCF would be a 5. So now let's look for the largest degree of x. That's degree would be the exponent on x that can be factored out of all the terms. It means it can be divided evenly out of every single term. Well, since the 45 doesn't even have an x, there is no x with an exponent that can be evenly divided out of all of them. So number 10, we have a 7x squared and a 21x to the first. You're really looking for the smallest exponent of x. In this case, it'd be x to the first. I could divide both of these by x, or some kids write it as x to the first, and it would divide evenly. Looking at the next one, I'm comparing the x to the sixth and x to the third. So the GCF here would be x to the third. I could divide both those by x to the third. And I have an x to the third, x squared, and an x to the first. So the GCF would be x to the first here. Again, you're looking for the smallest exponent. that they have in common. So now we're going to actually factor these polynomials. These are the same problems we just did in 5 through 12. So the GCF for 9x and 45 is 9. I'm going to write that outside my parentheses, and inside my parentheses, I'm going to put what remains after I divide each of these terms by my GCF. To factor means I'm going to divide by that GCF. So I'm going to divide 9x by 9, and the 9's cancel, and I have an x left over. I'm going to divide 45 by 9, and I'm going to get a 5. You can always double check by distributing the 9 to make sure you get 9x plus 45 back. So number 14, 7 and 21 have a 7 in common, and x squared and x to the first have an x to the first in common. So I'm going to divide both of these by 7x to the first. So the 7's cancel. When you're dividing like bases with exponents, you're basically subtracting. X squared divided by x to the first is going to be x to the 2 minus 1, or 1. You can almost visualize having an x squared divided by an x, and one of the pairs of x's cancel, and again you just get an x to the first. So I just have an x to the first, or x left over, and 21 divided by 7 is 3, but because there's a minus in front of it, it's going to be a minus 3, and x to the first divided by x to the first cancels. So my answer would be 7x times x minus 3. So now number 15. 8 and 12, my GCF is 6. That greatest common factor that 18 and 12 have in common is 6. And my GCF of my x to the 6th and x to the 3rd would be my x to the 3rd. So now I'm going to divide this by 6x cubed, and I'm going to divide this by the 6x cubed to find out what's left over. 18 divided by 6 is 3. X to the 6th over x cubed, 6 minus 3 is 3. There'd be 3 x's left on top. That wouldn't cancel with the 3 on the bottom. And then 12 divided by 6 is 2, and x cubed divided by x cubed completely cancels. This last one, my GCF is 5x. So I'm going to divide every single thing by 5x, and I need to erase this from earlier so I have some room here. And 15 divided by 5 is 3, and x cubed divided by x to the first would be x squared. 3 minus 1 is 2. And then x squared divided by an x would give me, this is a minus because there's a minus sign there. 25 divided by 5 is 5, and we were just talking about x squared divided by x to the first would be an x to the first. And then 55 divided by 5 is 11, and the x divided by x completely cancels. So what happens if it's negative, the leading term? Well, if your leading term is negative, you have to factor that negative. So for example, the GCF of negative 2x cubed plus 6x squared is not 2x squared. It's going to be a negative 2x squared. Since that leading term has a negative, we're going to put that in with my GCF. So inside my parentheses, since now I'm dividing by a negative, my signs are going to switch. So a negative 2 divided by a negative 2 is a positive 1. And x cubed divided by x squared would be an x to the first. And then a positive 6 divided by a negative 2 is a negative 3. And x squared divided by x squared cancels. Again, here, the only GCF here is just that leading negative 1. I want to factor out that leading negative 1. So I'm going to factor out a negative 1. Oh, I don't know why I wrote it that way. Sorry. Let me erase this. So equals, I'm going to put that negative 1 as my GCF, and then everything is getting divided by a negative 1. So basically all my signs are switching. X squared minus 3x plus 5, and this would be my fully factored form. The bottom gives you some problems you can try, and you can check your answers in our filled in packet and ask questions when you return to class. Good luck.